These are the answers to exercise 12.8, and we are doing or looking at how to prove congruency. So for question 1, it says, prove that triangle ABC is congruent to triangle PQR. Now, when we prove congruency, we have to have an introduction or state in which triangles we're working. So in triangle ABC and triangle PQR, and then we have 3 reasons that we need to find. It's either an angle, 2 angles that are equal, or the sides that are equal. So first of all, what are we given? We're given that AB is equal to PQ, so AB is equal to PQ, and this is a given. And then we are given that AC is equal to PR. AC is equal to PR, given. And then we are given that BC is equal to QR. So now we have our three sides that are given. So this is going to be, therefore, triangle ABC is congruent to triangle PQR. And the reason out of the 4 reasons, we've got 3 sides, so therefore it is side, side, side. For question 2, we need to prove that WXY is congruent to ZYXY. So if we look at what we're given, here we're given these 2 sides being equal. We're given WY equal to YZ, Z, and that this XY is a common side. So we've got 3 sides that are equal. So I'm going to start off by saying I'm working in triangle WXY and triangle ZXY, and then 3 reasons. So first of all, XW is equal to XZ, given, and WY is equal to YZ, given, and then XY is equal to XY, and that is because it's a common side, so I just write common. Therefore, triangle WXY is congruent to triangle ZXY. Once again, 3 sides that are equal. Question 3. Prove that triangle ABC is congruent to ZYX. So here we have AB equal to ZY equal to 3.5, and then we have both BC and XY is 3, and we have that angle B is equal to angle Y, which is 65. So starting off, we say in triangle ABC and triangle ZYX. So 1, 2, 3 reasons. So then we have that AB is equal to YZ is equal to 3,5 centimeters. So that is given. Then we have that BC is equal to XY is equal to 3 centimeters. It's given. And then finally we have that angle B is equal to angle Y, which is equal to 65 degrees. That's also given. Now, just as a final check, just to make sure that they are the right angles, the corresponding angles and sides, if I rotate this, or if I reflect it, actually, if I reflect this triangle downwards so that it looks like this, where my 3 is now at the bottom, my Z is at the top, my X will be here, and my Y will be here, then it should be a mirror image of this one. So this 65 degree angle lies here. We've got the 3.5 over here and the 3 at the bottom. So we can see that this is actually a mirror image because my 3.5 is on the outer sides, my 65 degrees are both on the outer sides, and then the 3 is at the bottom. So that was just to confirm that we do have the right angles and sides. So therefore, triangle ABC is congruent to triangle ZYX, and we have two sides and one angle. So the reason would be side, angle, side. Question 4, prove that triangle PQM is congruent to triangle STR. These ones are a reflection. If we reflect it through this line, we can see that this side is equal to this side. We're given that QM is equal to RT, and we're given this 90-degree angle. So in triangle PQM and triangle STR, for our three sides or angles that are equal, we have that PM is equal to SR, which is equal to 5 centimeters, and it is given. Then we have that QM is equal to RT, which is equal to 3 centimeters. That's given. And then we have that angle Q is equal to angle T, which is 90 degrees, and that is also given. So therefore, triangle PQM is congruent to triangle STR. My reason, since it's a right angle triangle, is we've got the right angles equal, the hypotenuse side, and then another side. Question 5, we're given that AE and BD are straight lines, so AE and BD. Then AB is parallel to DE, and AB is also equal to DE. So question A says, prove that triangle ABC is congruent to EDC. Okay, so for A, I have that I'm working in triangle ABC and triangle EDC. So I have three statements, and then first of all, I'm given that these sides are equal. So I can state that AB is equal to DE. That's already given. Then these two angles are vertically opposite from each other, so they are also equal. That means that angle C1 is equal to angle C2, vertically opposite. And then we are given that these two are parallel. So since they are parallel, this A and E are alternate angles, which makes them equal. So therefore I can say that angle A is equal to angle E, and that is alternate angles. So my parallel lines are AB is parallel to DE. So therefore, triangle ABC is congruent to triangle EDC. Just always make sure that when you write the final statement, that your equal angles are in the right order. So A must be equal to E, B equal to D, and C equal to C. Alright, so my reason, since I have two angles and a side, it's going to be side, angle, angle. Now for B, it says that we need to now prove that AC is equal to CE. So AC equal to CE. So we've just proven that triangle ABC is congruent to triangle EDC. And since we know that they are congruent, we can therefore conclude that the other two pairs of sides will also be equal. So AC will therefore be equal to CE. Question 6. Given JM and KN are straight lines, JL is equal to LM, JL equal to LM, and KL is equal to LN. So that's been indicated. All right, now we need to prove that triangle JLK is congruent to MLN. All right, so in triangle JLK and triangle MLN, we have our three statements, and two of them already given. We know that JL is equal to LM, given, and we are given that KL is equal to LN, that's a given. And finally, we can see that these two are vertically opposite angles, so they will be equal. So angle L1 is equal to angle L2, vertically opposite angles. Right, so therefore, triangle JLK is congruent to triangle MLN, and we have two sides and an angle, so our reason will be side, angle, side. Now for B, we have to prove that JK is parallel to NM. So JK being parallel to NM, we're going to first start by saying that since we have just shown that these two triangles are congruent, we know that K should be equal to N. That's some of the remaining angles of these two triangles. So since these two angles are alternate angles, and since they are equal, that means the lines that form these alternate angles needs to be parallel. And then we've shown that they are parallel. So to start off, I'm just going to state that we've just shown that JLK is congruent to triangle MLN. So therefore, angle K is equal to angle N, and therefore JK is parallel to NM. Then for question 7, given the quadrilateral QUAD with QU equal to UA, as it's indicated over here, angle Q is equal to U2, which is X, and then angle D1 is equal to angle D2. Alright, so in this case, we need to show that QUD is congruent to triangle UAD. So that means we need to say that Q is equal to U, which is this one, and we have to show that U1 is equal to A, and then D is equal to D. Alright, so we start by saying in triangle QUD and triangle UAD. So 1, 2, 3 statements. And for the first one, we are given that angle Q is equal to angle U2, which is equal to X. So that's the given. Then we are given that angle D1 is equal to angle D2. That's given. And then finally, we are given that these two sides are equal. So to get a better perspective of how these relate to each other, if I take this triangle and I just rotate it around this point, I rotate it up, then this angle will fall over this angle, this side will fall over this side, and this X will fall over this X. So then we can see that QUD, if I've rotated this up, would be UAD. If you have trouble seeing that, you can maybe sketch that for yourself. Alright, so that means that then that QU is equal to UA, that was given, and therefore triangle QUD is congruent to triangle UAD. And we have two angles and a side, so our reason is side, angle, angle. Then for B, I have to prove that U1 is equal to A, so we have U1 equal to A. So if I rotate the, like I've mentioned earlier, then this would be the two corresponding angles. So I can simply say that since we've shown that triangle QUD is congruent to triangle UAD, therefore these two remaining corresponding angles will be equal. So angle U1 is equal to angle A. Question 8, given that FG is EH and those two, and FE is equal, F is equal to E is equal to 90 degrees, prove that triangle FHG is congruent to triangle EGH. So once again, we have our heading in triangle FHG equal to triangle EGH. So we have three statements, and then for the first one we are given that FG is equal to EH, so that was given. Then for number 2 we have that angle F is equal to angle E is equal to 90 degrees, given. And then the third one we need to find. So if we look at these triangles, this angle being equal to this one and this side, then it means that these flat sides are both the sides that needs to be equal, and it's a common side. So I can say that GH equals to GH, so that is common, and therefore triangle FHG is congruent to triangle EGH. And we have the right angle, hypotenuse side and another side, so my reason is RHS, right angle, hypotenuse and side. Then for B, I need to show that G1 is equal to H2. G1 lies over here, and I need to show that that's equal to H2. Alright, now in this case, the two angles, the remaining angles that are equal is actually this G is equal to this whole of H. Those are my remaining angles. So I can write that down. I can say, since triangle FHG is congruent to triangle EGH, I know that G, angle G, is equal to angle H. And that was the second angle of the three angles of the two triangles that are equal. The third one is this small angle, this one and this one. So they are also equal because of the two being congruent, the two triangles being congruent. So now I'm going to state that, but I'm going to first, before I show that they are equal, I'm going to break, or actually let's just write it now. Let's say that angle G2 is equal to angle H1, and that's also a consequence of these two triangles being congruent. And now I can say that this angle G being equal, this, if I break this up, G1 plus G2, this angle G is angle G1 plus angle G2 is equal to angle H1 plus angle H2. But since we've seen that G1 is equal to H1, I can replace, or G2 is equal to H1, I can replace this H1 with G2. So G1 plus G2 is equal to G2 plus H2. So these two will then cancel each other, or if I take the 1 over, it becomes a negative and they subtract. And then therefore angle G1 is equal to angle H2.
And that's the end.